In Module 5, we're going to learn other ways to solve quadratic equations. This one is called using the square root technique, and we want to solve for t. So the first thing we do is to isolate the letter we want to solve and transpose the negative 12 to the other side. Now in class we talked about the method of taking the square root of something. Since this is squared, by taking the square root of this we're just going to get a t. But to ensure we get all of the answers and our negative ones as well, when we take the square root of a variable, to ensure we get all the answers, we go plus or minus the square root of 12. Now, our answer, you might think, is just the square root of 12. Well, in a sense, that would be an answer. But we know that the square root of 12 is the square root of 4 times the square root of 3. And what is the square root of 4? 2. So that is our answer. So t equals plus 2, the square root of 3, or minus 2, the square root of 3. So here we have a close relative of what we've done, where instead of just being a letter there, x or t squared, we have a binomial that's squared. And we're saying this binomial squared equals 25. So we use the same technique of squaring both sides, plus or minus this, the square root of 25, and this just becomes the radicand. Remember, there's a 2 there and a 2 there, just becomes the radicand. And then plus or minus the square root of 25 is plus or minus the square root of 5. Now we transpose our negative 2 to the other side, where it becomes a positive 2 plus or minus 5. So x will equal then 2 plus 5 is 7, and 2 minus 5 is a negative 3. Going on, and let's call this one number 3 here. I don't know if you recognize this or not, but this is a perfect square trinomial, and it will equal 9. So we can factor that into its binomial squared, which will be x. We're taking half of the b term here, which is 6. And if we just expand that, x squared is this, multiply this, double it is that, square this, we get that. So we can use that same technique. Take the square root of that, and then plus or minus the square root of 9. So this just becomes our radicand, plus or minus 3. Now we just transpose the 6, a negative 3, up negative 6. Let's see, I'm already working on my answers here. A negative 6 plus or minus 3. So x will equal then a negative 6 and a negative 3 will be a negative 9. A negative 6 and a positive 3 will be a negative 3. So this is going to lead us into our next topic, which is what we call completing the square. Now, in this one, the equation is in standard form, and we need to be familiar with the a term. Here, the a term, which is the coefficient of x squared, is a 1 that we don't write. Here, our b term is the coefficient of x, which is 18. And then our c term is a -4. And it's in standard form. Now, when we're going to use this technique, which is called completing the square, we want to convert this expression into a perfect square trinomial that eventually we're going to get something like this, and that will equal something, things that we've been doing so far. Well, the first thing we do is we take the c term, which is -4, and bring it over to the other side. So I'm going to erase this here. And I'm going to put that 4 now on the other side. But keep in mind, originally that was a -4. On the other side, it's 4. Now I want to make a perfect square trinomial out of this so that it looks like this. Well, remember we took this x here and squared it to get this term. We used that middle sign here. And what did we do to get this term? Well, we multiplied this by this, and then doubled it. Well, if this is a result of doubling, how do we find what this term would be here? And the answer is we take half of it. Well, what is half of 18? 9. Now, we are missing our c term here to make this a perfect square trinomial, and we get our c term by squaring this. This gives me an 81. So in a sense, I'm adding an 81 here. Well, since I'm adding an 81 there, I need to add an 81 there. So now these two parts of our equation are equivalent. We're saying that this equals that. And again, sequentially it follows. Now, when I add my 81 and the 4, I'm going to get 85. So now I have it set up where I've taken factored this into its binomial squared form, and now I can use my technique of taking the square root of this side plus or minus the square root of that side. So this just becomes x plus 9 equals plus or minus the square root of 85. Now I transpose the 9, and I then end up with x equals -9 plus or minus the square root of 85. Now in MATLAB you usually have to put these in separately. A -9 plus this, a -9 minus this. These are your two answers, and this is how we found them by completing the square.